it's about that time we get started. Find a friend with a compiler. We will have some more exercises in a little bit. So how many were not with us for the first session? Okay, there are a couple. So just to quickly go over what we covered in the first section. Started off with functors, and we talked about RAII, type traits. We talked a little bit about schema. We talked about concepts, not the concepts you were talking about, but in a way we were. So what are concepts? Generically, what are those things?
Set of requirements on a type.
Yeah, set of requirements on a type that have to be obeyed in order for that type to be usable, right? And so while we were talking about them over here, they were talking about how to actually make sure that they're right over in another room. So let's see. Moving on now, let's go ahead and talk about, oh, that's right, some of you just joining us, so let's at least do this. If you don't have this book, you should. And if you don't have this book, you probably should.
Your book is right there. What was the Myers? You know the Myers book? I got your number.
Yes?
Hey, what was that first book?
Too late. Modern C++ design. And the slides will be available online soon. All right, so now that we've done functors, RAI, concepts, policy classes, CRTP, type traits, and we jumped over to schema, we're going to come back and do some tag dispatching, and then follow up with some other EPL things. Remember, this is an introduction to modern C++ techniques, which means that you will not leave with the knowledge and abilities to do everything you probably want. You probably get to go off and read the books that we were mentioning earlier, one of which the author was over. The other thing, if you're just joining us, when we're talking about modern, we're not talking about necessarily the C++ 11. We're just talking about techniques versus of what we might want to do today versus what we did 20 years ago. And if you remember the other title to this, the subtitle is The Session I Wish I Had My First BoostCon. Because though I had been programming in C++ for 20 years, I was really new to most of these ideas and concepts. And I was like, wow, this is a whole new world. This is a different language. This is not the language I've been using. And the power in it was extreme. It was pretty amazing. Right away, the things that I took away was, I want to get the compiler to do as much as possible up front so I don't have to do it later. And so a lot of the techniques we've been talking about so far have to do with that, right? We want the compiler to make decisions so that our code runs fast, and it's made selections for us already, and we do that by giving the compiler as much visibility as possible to what we're wanting to do. So remember, one of our favorite words at the moment for about everything that we've been using is what? What do we put in the front of a lot of our definitions or declarations?
Boost.
Boost. Boost has been a lot of them too, actually. Static. Static so that the compiler can see what it is that we want. And we've seen a couple of examples where it has to go through a few gyrations before it can figure that out. And now we're going to start with something called tag dispatching. And we're going to find that there are a lot that we can go through before we figure out what in the world we want. But that's okay, because the compiler is going to do it for us. So, have we got the compilers ready to go? I'm trying to think of, I think we get to talk for a while, and then we'll do some examples here. So old school, how we did a lot of things, we had common bases. And the problem with common bases, or a problem with common bases, is they're intrusive. It means if I have a data type, like a point, it either needed to inherit from a base type point, or somehow had to be the point itself for me to use it in all of these applications that worked on points. It was pretty old school, and if I wanted my point to be able to be passed around, there would be virtual inheritance, and I would do that by inheriting from something. So now I'm putting stuff in my code, maybe some methods, so that data can be accessed. I'm doing something to my original class that I don't want to do. And there's problems with that, right? What's one of the most obvious problems with having to modify my class so that it's compatible with functions that I might want to use? Can I always modify my class? No, sometimes I can't, right? I'm going to get maybe something from a vendor, and I need to use these points that are coming out of maybe an Adobe package. And I can't just go in there and modify it. I've got a data type. I have to use the data type the way it is. I can't make changes. So it was restrictive, or what we would do is we would create runtime wrappers, right? We'd start wrapping everything. So it's okay, I have an Adobe point, I'll just wrap it in my other point that inherited from my main point. Anybody ever written any code like that? Okay. You're all showing your age. Some of you have. So modern. We've already talked about Sphena, and now we're going to talk about some tag dispatching. It's non-intrusive. It's generic. I can write my methods, my algorithms. I can think about what I want to do with my data in a generic way that won't intrude upon my data types. So it's compile time, which means if I'm lucky, right, everything's runtime fast. I'm not making these choices at runtime. I'm making choices of what to do at compile time. All right, let's start with point. We're going to talk about just trying to figure out a distance between 2 points. If you weren't in the first session, I mentioned in the credits section where some of this stuff was coming from. This in particular comes from Baron, and the Boost Geometry library has a whole bit about the basis of how it's designed, and which uses tag dispatching. So a lot of this information that we're seeing right now, you can go back later and say, hey, wow, I've read that, or I've seen that somewhere. So we have a my point. My point, very boring, with a double X and a double Y. And so now I can calculate distance with my very cool distance function. It takes a my point by constref, an A and a B, and it returns double. We all know how to calculate between 2 points, the distance, so we do that, and we return. It's great, right? Everybody's happy until you come around and you mess up my system with your point. Huh. It's not so messed up. I wonder what happened there. Trust me, it's messed up. Your point is very different than my point. You're going to have to believe me at the moment. And so then we decide, though, that it's okay. I have my point, and you have your point, but we know how to calculate distance between points. And so I'll just template the type, right? So now I have a point coming in with an A and a B, and I'm using P1 and P2. So I'm taking, the points can be of 2 different types. Why is that important?
So you can compare my points with your points.
Yeah, my points and your points, we can calculate distance between the 2 of them, right? It's not so bad. So I don't require it just to be my points or just your points. But your points and my points, they both work together. We're friendly. You just didn't like my name and you liked your name. So we can calculate and return our value for the distance between the 2 points. We're good, right? Everybody's friendly. We're happy.
But if my point was in feet and your point was in meters,
No,
I'm not happy now.
we're not happy anymore. Yeah, you're gonna start annoying me. Yeah. But it's okay because we have like another 60 slides to tag. So we're good. I suspect by the end we'll be able to handle almost anything. Like your secret point. So I have my point, and you have your point, but this guy's not playing nicely, and he has a secret point. So, secret point unfortunately has a get x and a get y. That totally breaks my distance calculation. My distance calculation said that types have x's and y's in there, and he has a get x and get y method. I don't even get to see what these data types are. It drives me nuts. You're so unfriendly. Now what would be cool is if instead I could just say, what I really want to do is get the 0th thing and treat that like x. And then the 1th thing, words, and then treat that like y, and then calculate. Because then it doesn't matter anymore, right? If I can somehow abstract away x's and y's to get the first and get the second, and somehow firsts and seconds are going to describe a point in the 2 coordinates, right? In the 2 dimensions, in the x and the y, then things are good. So how might we do this? Any thoughts? Good. So we've seen traits already with a slightly different flavor. We're going to create a namespace called a trait. And we're going to create inside of it this struct called access. And it's going to take a type and an int. And with this then, I can say my point, when I specialize it, my point, specialization 0, is the same thing as this, my point 0, specialization, and it has a method called get. And it's going to take my point by reference, and it's going to know I have a my point, and the first thing that I want out of it is nothing more than returning p.x, because my points have x for the first one. And my second one was called y, right? So this isn't so bad. And we've seen this so far, right? We've seen a lot of this taking a template and specializing it for something. So remind me, why do we have static here?
Compiler.
Right. We want the compiler to take care of this at compile time. We don't need to be making objects of things. At compile time, we want it to be able to look through and get what we want. All right, cool. So now my points have ways to get for the first and the second, which are my x and my y. And secret point is just a little bit different. If I'm going to specialize on secret point, I can't just look in and get x and y. I have to call get x and get y. Yeah.
So I understand that you're using this to illustrate tag dispatching, but this particular example looks like it's screaming out for sort of a traditional generic programming free function getter approach where you just use argument dependent lookup to find the get function. And I was wondering why you didn't go that way, or is it just because it's a handy example?
Large amounts of things are for handy examples because they're going to build on each other.
Okay.
This is actually how Baron does it too in the Boost Geometry library.
Well, that's no excuse.
It's not an excuse, but there is a reason.
I'm just kidding. Okay, thanks.
You're welcome. All right, we good with this so far? All right, so now we can make our specializations regardless of my point, your point, secret point over here. And we're going to be able to get out our x and our y. All right, this is a lot of typing. And it would be really annoying to type this type of stuff all the time. Trait, access, point 1, 0, get. right? That's what we have now out of this. Trait namespace. Access, it's specialized on the type and the cardinal. And then we have this get method. I pass in the A. Everybody okay with this? If I have to type this every time, I'm gonna not like writing code like this anymore. Real fast. It might solve my problem, but you know, I might not want to solve it anymore. So let's see if we can fix this. We're going to use a proxy. We're going to create a template function, get, that returns a double. It takes some key type. Here's the cardinal. And now, it will go ahead and do the long typing for me. So now P is a parameter inside for get, but D isn't. So what do I have to do when I use get? Yeah, and it's like get D, right? Get angle brackets D, because the D's got to be there somewhere. So now I have my get 0 A, get 0 B, my get 1 A, and get 1 B. Makes me pretty happy. Doesn't take much, right? All right, so we did it. We're done, right? So we have our generic point. Very excited. All right. We're going to take a little diversion, because we weren't really excited. That was the key, right? We're never excited. If the question's at the top says we did it and it's got a question mark, the answer is probably no. So let's take a little diversion. You guys remember, if you were in the Lambda, remember we had this recursive calculation that we did with Lambda in order to figure out factorial. Because factorial is one of our favorite things to calculate recursively. So we have fact4 down here. And what is this doing? Well, I have my function that has a signature, takes an int, returns an int. Now I'm going to assign it the closure object after this is evaluated, in which I'm passing in myself by reference. This is a capture, remember? Takes an int, returns an int. Normal factorial stuff. Called fact of n minus 1. This recurses through, I get the right thing. We all know how to do this at runtime, right? All right. Exercise time, because you guys are all falling asleep. It's getting warm in here. Now, pull up those compilers and do it at compile time. We want to calculate the factorial at the end at compile time, print the result for 3, and the result for 5. There's less rapid typing this time than there was earlier. Where's the guy with the phone?
Right here.
Oh, man. Look, if he can do it on the phone, the rest of you could at least do it on paper.
Clearly it's going to begin with template.
Good start. Did you memorize that in a macro on your phone yet?
No, it's not allowed to complete the template for me yet.
Not a completing template yet. I can tell you now, if you're in an interview and you said something as silly as, I'm an expert with Boost, somebody will ask you this question to make sure you're not lying. It'll be the first one they ask. Interview may be short.
That's always the first question I ask when I
good neighborhood sound on Zoom. Makes me happy. Victory over in the corner. Good job. Sometimes it's just fighting with the compiler. Spelling errors. Somebody have an approach that they'd like to talk about? Did you? No, wasn't it?
I can.
Yeah, go ahead.
So you can define a class that takes as a template parameter an integer value,
Okay.
and then inside of it declare an enumerator or a static int with a named value that has a default or is initialized with the value n times the factorial of, and then pass it n minus 1 as the template argument,
Okay.
and then specialize factorial for either n equals 1 or n equals 0, and set value equal to 1.
All right, awesome. Very good. So let's take a look. So this was my first attempt. So it's not a type name, it's not a class, it's an int, right? I want to be able to have the template parameter be an int for factorial. And what am I going to do? Value equals n times, and then factorial of n minus 1, and then its value. So factorial of n minus 1's value, which is whatever it worked out to be, times n. So we have this recursive thing, right? But if you let the compiler recurse, it will be happy to do so for a period of time. So you should probably stop it, just like you would normally in runtime. And how do we stop things that we don't want to keep recursing in compile time? We specialize. So you specialize on either on 1 or on 0, right? And so at this point, value is just 1. So we start off, we throw in of 5, and so here it is 5 times, and then it's going to create factorial of 4 minus 1 will be its template parameter, colon, value, which continues to recurse down and do the same thing. Now, for those of you who are starting this more recently, yours might look like this, where compilers seem to like static constant values instead of doing stupid things with enums, and it just reads better, right? So here we now have our static constant value, same exact thing, right? They're identical. All right, make sense? So with templates, we can recurse. It's really great. We get all kinds of cool things with it, as long as we remember to specialize so we can stop. Is there a question?
I was saying up to a point it's the same, but if you get beyond what the int can express, then you're pretty much stuck with that.
Yes. What are you wanting to express? Foos?
I'm just saying, if you use enums, then that doesn't happen that easily.
I see. Yeah. For my factorial, this works great. All right. So let's move on. There's a reason we just did that little exercise. I was really, really happy until somebody in marketing decided that we don't just calculate distances on planes. And they decided that, you know, everything we do is in some type of in dimensions. And now I've got to get fancy. So now we're going to get fancy because this might not be just 2-dimensional points, maybe they're 3-dimensional points. we're going to get z's now. But we won't call them z's, because, I mean, I call them z's in my point. And the guy with the your point over there, he called them j's. Yeah, some call them elevation. All right, so we have this. Yay for Pythagoras. Let's just figure out how to implement this, because that will solve our problem. But again, we don't want to do it at runtime, right? We want to try to figure out how we can implement these things so at compile time we get the right behavior. As much as possible, we want to occur at compile time. So, type 1, the type of point number 2, and now we have this apply. And apply is going to take whatever the dimension is, minus 1, and it's going to get its value out. It's going to do that for B also, and then it's going to multiply, it's going to square D, and then it's going to recurse down for D minus 1, and do the same thing. So it's going to do this, right? The difference squared plus the difference squared plus the difference squared, square root up. So we're getting this part down. And we're going to add this in so that we stop. So when D eventually becomes 0, because we're going D minus 1, D minus 1, D minus 1, when D becomes 0, we're just going to return 0. We're going to add 0 at the end. So we've handled this body in here. Does that make sense? So we're still using our get. As long as we have gets that can handle gets of 0 and gets of 1 or gets of 2. We can handle 3 dimensions. So what's the next step here? Well, let's change our distance. This is what we had before. And now we have this. The square root of our Pythagoras, specialized on the points, and this thing, dimension P1 value. And then we apply. So, any idea what this dimension P1 value must be?
Number for x, y, z, or number of points.
Okay, the number of dimensions. And do I have to add that into my point in order for this to work? Did I have to, inside of my point type, have in this thing called dimensions? No, because it appears that I'm using the same trick that I've been using a lot of, right? Which is, there's probably some specialization of this struct called dimensions that's going to take a type, and return a value. So again, I get to not be intrusive with my type or your type. Now, what's this fanciness up here? Anybody know what boost static assert does?
Gives you a compiler at compile time if those things are not equal.
Right. I'm going to get a compiler error, and I didn't add the message, but it would be nice if I did, right? Because we can add messages to static asserts. And it could have said something like, hey, bozo, these two types have different dimensions and I don't know what to do with them. So at this point here, we're ensuring that the 2 points that I might be trying to work with, your point and my point, at least have the same dimensions. If they have the same dimensions, then I don't really care how to access the data in them. I can use them. So once I've ensured that they're the same dimension, then I can go ahead and just use P1's dimension value here.
Wouldn't there be a compile error later on if you didn't have the static assert, because one of, if say value was 3 and one of them only had specializations for 0 and 1.
But that would be really inconvenient.
Okay, I'm just confirming from my understanding.
Yeah, you're eventually going to have a problem.
There would be a compile error. It's not a very clear one.
Right. You want to, as early as possible in the most convenient place, provide an error. So at this point would be a better place than as it starts going through and calculating with all the gets things that it may not have. That would just be confusing because it's going to come back and say something like type foo, no specialization of get 3 or something like that, right? And you're going to get one of those. Has anybody ever gotten like an error out of Boost before that you didn't understand? Oh, okay. So you're going to get one of those. So you prefer not to have one of those. And how you stop that, right? How the library authors stop that. And most of them are really good about it, so I shouldn't tease. Is they use Boost static assert, and they usually put messages in there, and it'll say something in your compiler. So if you guys aren't aware of this, look for the thing that is like star, and then some message. You'll have like just CRUD, all kinds of compiler warning, and then then after that errors after errors, and you don't know what any of it means. Just look for the star, and there's a static assert, and it's probably going to tell you in there what the problem is. And if it doesn't tell you right there, you just follow into the source code, and there would be a really nice big comment right here that would say, hey bozo, the types don't match and they have to match. Something like that. Almost all the authors do that. Okay. Wow, this is so exciting. Now, I can take, whether it's my point or your point, as long as they're the same dimensions, I can calculate the distance. So let's take a look and see what dimension is. It's just a trait, right? So, my point, I'm using this fancy MPL int of 2. We saw this earlier, though we didn't know we saw it earlier, because I showed a slide that I shouldn't have probably, where we mentioned you could inherit from MPL types in order to get some information. You could become a type that represented some information, and they would also have a value in it. This is going to give me a value of 2. This thing is going to become 2. Make sense? We're good so far. So now we've seen something here that we should point out. Value, and we've seen apply. And these are the terms that we'll typically end up using for when we're wanting to get a value out or do more work. All right, exciting. Except for that would be ugly to type, so we don't do that. We're going to go ahead and create this. So here's traits, and then this would be dimensions, my point, la-di-da, which we just have dimensions P2 value, right? We don't have traits, dimensions, and all that other crud. And so how can we get rid of that? Well, here we've inherited from traits dimensions. And what is it that we said just a moment ago that got us when we inherited from MPL int? It gave us the value 2. So there's a static constant 2.
Could you pull that dimension using a using statement?
Pull that in using the using statement.
In your CPP file, for example, instead of dividing off of it and making it a dimension that's not in the traits namespace, you say using traits : dimension. Does that work?
What are you trying to get out of it? Just not having to write this?
Right.
Oh. Just write. So, you probably could. You're messing up my slides. No, I'm kidding.
Then every user of that would have to do that.
Right. This way you're exposing your interface, right, of what you want. These traits, where are these traits? We probably should talk about that.
Detail.
What's that?
Detail.
They might be in some detail. Whose detail are they in? They're in my point detail, because I'm going to try to make my point work with your distance algorithm, right? And at some point, all I need to do is now figure out how to do the gets in order to get what my values x's and y's and z's are, and I have to do this dimension thing. But somewhere I'm going to explain to this distance thing unobtrusively how to access the members inside of it. This then is going to be utilized though with inside of my distance library. This is how I want to type it. You type it like this, I type it like that. All right. So now we have this. Very exciting. We did it, finally.
See a question mark.
Okay, yeah, so there's another question mark. So at the moment, what do we have going for us? Well, my point and your point can be of different dimensions and of different types. Why might I be unsettled with this? Anything else that could be more generic?
The double.
Yeah, the double's kind of annoying, right? So I have this return type that's not very generic. And double might work, but then again, double may not work. So it depends on what world you come from. We have two geometry libraries in Boost. Why in the world would that happen? We have one's called Boost Polygon, right? One's called Boost Geometry. They come from different backgrounds. The Boost Polygon guy comes from a background where there's a lot of Manhattan geometry, and he works with masks. He works with data set that's on chips. It's a world that I came from. I understand why he has certain things that he does. He also is interested in integers, because steppers and e-beam machines use integers. We don't use floating point numbers. That would be ludicrous. We don't even know what that means. So Baron, he comes from a different world. He comes from the GIS world. And that's what he happens to use, right? So what did Baron do? He goes, well, you know, there's lots of different types of points to return, and that's a good question, right? How are we going to return this? So let's figure that out. Yeah, type is double, sadly. So let's figure out how to make our return type no longer a double. What we might do? How can we maybe do this? There's some pattern that probably has the word template in it. Yeah. All right, let's take a look if we can figure out how to create a coordinate type. So we've described a bunch of different things now. We've described that our number of dimensions. We've described how to get and access data out of our types. Maybe we should also describe what type of coordinates we want to deal with. So, for my point, I want to use doubles. So I'm going to specialize coordinate type for my point so that type is a double. So now we've seen in metaprogramming 3 different things. Values, when we're trying to get a value out. Type, when we want to get a type out. And apply, when we want to do something else. Another meta function. And what's this thing then?
It's what we just did with the dimension.
It's what we just did, right? It's that proxy, right? So I don't have to type all that crap. It's my proxy. So we could do this now for my point, and we could do this for your point, and we do it for secret point, and we can do it for any point we want to add. We do it for points that we get from a library system, and we can do it without adding more stuff to the point types. We do it somewhere else. It's not intrusive. Not only that, we're creating these structs, and type defs aren't a runtime thing. So again, this is something that's going to happen at compile time. The compiler, again, is going to be able to figure out what it is that we want to do. We're getting as much visibility as possible. Okay, now we just have to figure out what we want to do with coordinate types. Oh, boy. How exciting. So now we have this, which is what we had before. But it would be really cool if we could return some computation type instead. So these things almost look the same, right? What's the difference between them? The return value. So all we've done so far is we've changed the return value. Now we just have to figure out how we want to create a return value. How are we going to create computation type? Yeah.
Called standard comment type.
Standard comment type. Okay. What if you want more control over it? I mean, what's standard comment type going to do for you?
Takes the 2 types and does kind of what the rules are for the 2 types. And
Right.
makes that a
But what?
type.
what if you lived in the world where you really just want integers? And rules about how to get those. It's possible. So you'd like to be able to provide more control. So let's figure out how we can get more control, because somebody earlier was talking about being a control freak. I don't remember what session that was in. Oh, it's the real time. All right. So we have our computation type, and we just need to figure out what this is going to be. And we decided, for the moment, we're going to select the most precise type. So type def, type name. Why do I put type name? I don't know what it is. We're going to tell the compiler it's going to be a type, right? Because it's dependent. And this select most precise, the coordinate type of P1 type, and the coordinate type of P2's type. This, whatever the select most precise meta function is, it's going to have a type that we can get out of it. That will be the most precise type between the two, and that's going to be my computation type. And now I have something very generic. And this is the best part about doing modern C++ programming. How many of you have been really upset about faster computers and compilers? There's no time to have coffee or have sword fights anymore at all. The problem is you're just not doing enough metaprogramming. You do more metaprogramming and there are more coffee breaks and sword fights available. Yeah. You don't have to worry about those nice guys back there, IBM and the Intel guys trying to figure out how to make processors faster. All right. Does that make sense, that tag dispatching thing, what we're trying to do? The big advantages of it are that we're taking care of giving the compiler visibility of what we want. And we could have done all this in runtime too, right? It might have even in the past. But we're allowing the compiler to take care of it by giving it visibility, and we're doing it in such a way where we've now been able to create generic things that act generically with some behavior, and it's going to be fast at runtime, right? It's going to be able to select this. Most importantly, though, with the whole tagging, we didn't do it intrusively. It doesn't matter if Ed comes up with the most amazing point in the world, and now I can't figure out how to cram it into the system that I had in the past, because I can create all these different things, right, in order to help describe what Ed's thing is. I can create traits on how to grab out the information that I need out of Ed's point, so that I can utilize Ed's point with my really cool algorithm. So Ed came up with an amazing point. I want to use it with our amazing algorithm. Make sense? All right. Your turn.
Michael,
Yeah.
if let's take a use case where my point is the only implementation I have.
Yeah.
And I don't need generic.
Sure. That's probably where you
So
started.
Is this still a
No,
way to go?
not at all. If your point is the only point you plan on ever having, then that's how we started, right?
Correct.
And then eventually what happens is, somewhere along the line, you're probably going to have to integrate with somebody else's stuff. And when that occurs, then at that point you may want to start thinking about, how do I do this generic? You're not going to necessarily write generic code right off the bat because you have this one type you ever do. Now, who's going to write generic code right off the bat? What classes? Library writers. Yeah. How many in here primarily deal with applications? Yeah, exactly. Library writer jobs, those are really hard, right? And we just saw trying to calculate only the distance between 2 points. And to be honest, we actually didn't finish it, right? We finished it for a Cartesian type system. We have Pythagoras in there. But what if I'm a GIS guy and I actually need to calculate based upon a whole lot of different types of calculations that aren't going to fit inside of that space for calculating for distance between points? Library writers' jobs are really, really hard if you want to write really good generic libraries, right? So the rest of us, what do? We write it the way that is going to make money for the company initially, right? That's our job. Companies exist to make money unless you happen to be Bryce, wherever he is, I guess he gets the right code and throw it away the next day. So the rest of us, though, we got to make money for our company, so we're going to write the code in an efficient manner. But then, when we have to go and modify it, we might want to think about it at that point and say, hey, this is going to be introduced to something that's going to require more generic behaviors. How can I do that? So hopefully we can get some tools here. Yeah.
The reason I asked the question is there are like two things, right? One is having a generic code. Second, the one that we saw earlier is polymorphism.
Yeah.
One-time polymorphism, having an inherent cost versus
Right.
we have another pattern that we
Right.
implemented. So would you ever choose that approach?
Yeah, okay, so I'll tell you what I do. When I look at something I'm getting ready to implement, and I know I want polymorphic behavior, I ask myself, do I want runtime polymorphic behavior? Really? Sometimes the answer is yes, but not very often. More often than not, the answer is I don't really need runtime polymorphic behavior. I can get it at compile time. And then we use CRTP to do that, right? But you just look at the domain, what you're needing to do. Am I going to be trying to iterate over base pointers? And I really need virtual functions because I'm trying to dispatch to something because that's what I really have? Or is it I have that because that's the only way I've ever thought about the problem?
I mean, my third point is the other factorial example.
Yeah.
The n that we want to supply has to be known at compile time.
Right, absolutely.
So once I compile, I want a factorial for like 20
Yeah, you can't
versus
do
30,
that.
I compile my code again.
No, yeah, you don't want to do that, right? But there are things that we do calculate at compile time, or I should say there are things that we sometimes calculate at runtime that didn't need to be. So just consciously make that decision.
Another thing too is that as you go down that road, your code becomes less readable to more mortals. We're used to looking in header files and figuring out how things work.
Yep.
And so now you have to document a lot more.
Okay, so what is it that you have to document? Like if this was our point class, or I should say our distance algorithm that we're going to now give to the rest of the world because it's so amazing. What is it that we have to document? The interface, and how do we document that interface? What did we call that earlier?
Concept.
It's the concepts, right? And we need to know what those look like. And so if you wanted to go and look at what good concept descriptions look like, you might go to the Boost documentation, right? And see how they do it. That's what I do. And because that's what Boost is, right? It's just like they're describing to you what the concepts are of these types. These types have to meet these different, all these different concepts in order for it to work. If it doesn't meet them, then it won't compile. I'll do the wrong thing. But you're right. So I tell you what I see in industry is that there are people who are really good at writing applications, and there are people who end up being really good at writing libraries. And when you're writing a library, what you're interested in is the interface to your user. And they're very happy, those people typically dealing with all the very ugly stuff below, but the interface to the user has to be elegant. It has to be something they're just not going to mess up. I'll give you an example. 3 weeks ago, I was at a client, and they had a thing that they were trying to solve in which they're going to need to know type information, in essence, but they were holding it in enums between two places. Somehow they're going to have to describe this exact same information inside of the library as they were somewhere else. That would have been a really bad interface to end up with, right? What the chances are of getting those out of sync. So the right answer was to find the library guys who could take care of abstracting that away so the interface was nice and clean. But you're right, that it becomes hairy down below. Oh, no, you guys have to see this. This is profit. You saw profit earlier, right? We calculated profit a while ago as an exercise. We're going to calculate profit again, which is, how do I fix this? It really is output divided by input. And then it's multiplied by 42, but it's fixed here on this slide, so it doesn't matter. And the people that we get this from, you know, this assignment, they happen to know that they already want this back as a float. That's all they ever want to see, ever. They don't want doubles. They don't want to do with them. They just want to float back. But they want us to be able to calculate output divided by input times 42. It's going to give them their profit. And they need to do this for whatever the types are that are coming in. All these types are coming in. And it just so happens that I gave this to Woodsy as a project and said, I am going to C++ now, and you're going to stay here and work on it. So you guys all get to pretend like you're Woodsy this week. And this is the type of things that you're going to see, potentially. You're going to see a vendor type that has a float inside of it called output and one called input. And it happens to come from this function called get in out. I don't know, but it's from the vendor and I can't change it. Get in out returns this type. I'm going to also have to deal with things like department. And department has two methods. One's called get widgets and one's called get managers. Those don't sound like output and input at all, but the people who count beans told me that output are the widgets and the input happen to be the managers. So if you are some department, if you took the number of widgets you created and divided by the number of managers in your department, you start figuring out what your efficiencies are, I guess. And then there's this other type you're going to have to deal with called software engineers, which if you ask it CPP now a 10 count, it'll tell you how many times this particular software engineer has been to CPP now, daily cups of coffee, and the manager count. And it just so happens that output's a little more confusing here. Output is the years attending C++ now times, oh, this is supposed to be the cups of coffee. It got messed up when I changed my thing. Times the cups of coffee. All right, so the number of times you've been to C++ now times the number of cups of coffee you've had, that's going to tell you your output. And the input, again, is how many managers you have to report to. So we've got all of these ways to deal with. Profit is still this simple equation, right? We've got a simple equation for calculating profit, but we have all kinds of different types that we need to deal with. This is just like the problem we were doing with calculating distance. We've got all kinds of different ways to describe what a point looks like, but we have one way to calculate this. We have one way to calculate profit. We just have all kinds of different types to figure that out. Your job, you don't have to do all three. Pick one and figure out how to write the profit equation such that it will dispatch based upon the type and do the right thing. The guy with the phone is amazing. You guys aren't even typing yet. He's just like, he knows he has to start writing template. Template. All right, so what I recommend is as you're working on it, if questions come up, ask them. Can I take a picture of you writing code on your phone? Do you mind?
Sure.
This is amazing.
That's one week worth.
Is that right how you do it?
By the way, you will want to let your managers know later that the more times you attend C++ now, the better the profits go to come in. Don't tell them about that part.
Yeah.
There's less wild typing, which means y'all are thinking about the problem. Exponential. So very often, a great approach to figuring out how to start writing something generically is to write it not generically. And then figure out from what you have, what would have to become generic. At least you have a base to begin with. Getting to the point where the compiler is telling you things like, you can't do that because you don't have an object, it means you forgot the word static. For everything is static. So we have a signature for their profit method they want to share with us.
Which one? That's
We have, just like we had one distance we were calling, right? Somewhere we probably have one profit method that we start everything off at. What's your signature look like?
float profit, template, class T, float profit, const T input, const T output equals 42 times output, float output divided by float.
Ah, okay, so you're passing in the input and output both?
Yeah.
So may I have another approach that they're working on? It's like a race and you don't want to take your fingers off, I understand. What are you doing there, Andy?
Template, type name T, float, profit, T, const, ref, vendor.
Okay, all right, so Andy's passing in the entire, a reference to the entire object. Okay. Here's my guess then, inside of that method, you probably have something that looks a lot like this, but it needs to figure out how to access output and input for those different types of my kit.
Right, I dispatched you a details getter.
Okay, so Andy's dispatching based upon his type to a details getter to be able to figure out how to get output and get input based upon the type. Okay. Anybody have a different way that they thought about this? They want to share? Tobias has that look like the compiler told him something. No. Okay. Or told you too much. Room warm, anyone else? The Wi-Fi doesn't work in the camp.
It's one with the energy of hardware.
Right, hard work. Were you not typing, it would not be so warm. Then you would all be sleeping. I've lost my excuse of jet lag and first day in altitude, so. You guys about another minute here to whip your compilers into submission. I took the same approach Andy did. And I'm sorry it's small. It is. So let's just jump down to the bottom down here. Profit turns a float, takes type T const rep, and then it returns 42 times tag profit T, the output, giving it the reference of the thing that was passed in, divided by profit T input, passing it in. So here's my dispatch, right? Letting somebody else do the work, and it's going to happen at compile time. So now I just need to specialize on things. So we have the three different ones. First, remember, we got to start it off by saying that this is the generic version. Now we can specialize it. So the generic version of profit has nothing in it. That means if I haven't implemented one, I'm going to, like the compiler will complain to me, right? They'll tell me, hey, there's no foo. Okay, so here it is for vendor type. Static, right? I'm returning an int. The output is vendor type as the v.output, and it's very simple, right? v.input got me my input. So vendor type was really easy as far as what code I had to worry about in here. Of course, everything was easy if you were only worried about the code right here, right? It was trying to get to this point. So the code in here is just return output, return input. So vendor is not a problem. Department, we're going to return the number of widgets. That will be our output. And we're defining our input as the managers. So notice it's kind of a cool thing that just happened by using this method too. I was able to tell what the mapping was. I was able to say, within my domain, there's a mapping within this type of what I consider outputs and inputs to be. And for a software engineer, of course the mapping is complex. So we're able to aggregate some things about the software engineer in order to figure out what its output is. It's not just simply accessing a method or a single member of the software engineer. It requires us to take the number of times that they have attended this event, multiplied by the cups of coffee they've had for the day, and that will give us their output. And their input then will be the manager count. It's pretty close to what you all got? Or at least headed in that way? Were there problems that you hit along the way that you have questions about? Perfect. You're all still working on it. Aha. Yeah.
Turns out I got exactly what you got.
Yeah, I do have interrelations. It's not necessarily the right thing, is it? What will happen, though?
You have a lot of error.
Yeah, I could possibly have a lot of error. But I'm thinking most of my error is going to come from just the managers meeting up.
What would be result compile time in this case? We have, for instance, each input or output function is static. However, what they are returning is something that.
Yeah, great. So that's a great question. So what does the compiler end up doing with this? You know, if I'm using Profit with a type that is a software engineer, it can look in and figure out what to do with all this stuff, right? And here, this becomes inline. So that's pretty cool, right?
So I mean, so to make sure, in runtime, it won't happen that in the case of software engineer, the static output method of Profit for software engineer will be called, and then those two functions. It's just what.
Right, exactly. Because at compile time, the compiler can figure this part out, and at runtime, it just needs to go ahead and make the access of the count and the coffee, multiply them together and return it. So we get the runtime parts we want, and we don't have to pay for the parts in order to get there. So you may have in the past implemented something like this in a different runtime mechanism, right? But you would have been paying for all the price in order to get to the point where you can finally just do the calculation. Here we just wipe all that away. Well, we don't, but the smart compiler vendors do for us. And we get to drink more coffee and sort by.
So I did it differently.
Okay, yeah.
And instead of having classes, which I specialize, I just had 3 functions I specialized. But I like yours because you had an empty profit was your generic version. So I had my generic free template function just didn't have a definition.
Right.
So when I compiled, I got a link error.
Yeah.
But you would have a compilation error, which is good. So I gave myself a definition, but I put a static assert in it. But it hits the static assert. I thought it would only hit the static assert if I actually instantiated that template.
So somewhere along the way, I missed what you said, but I'll take a look.
Sure.
So you brought up a good point, right? In order for errors to occur, we have to instantiate the types for them to occur. They just don't magically occur. So sometimes you'll see in code places where we will instantiate something in order to check the goodness of it, right? Does it fit certain concepts that we want it to fit?
The static is the highest because it's not dependent, so it gets instantiated as the first bit of base highest.
Thank you. All right, we good to move on? Yeah.
Well, or maybe you're going to go into it next, but on the vendor specialization for the first one, they were floats, and you've changed them to ints right there.
Yeah, that's probably just some type to the smarting type problem.
Okay.
More than anything else. I mean, it's going to cast them to an int, right?
Yeah, understand that. Okay.
All right. I definitely produce an energy amount of widget. Absolutely. All right, we already did that because we skipped previously, and so let's move over to here. All right. So we've been talking a lot so far about, oh yes. Did I make one up? This one? Yeah, we discussed this earlier in the first session. Though I did make up a word, it is not a failure. So it'll be okay. Yeah, now that has to do with you make changes to LaTeX, but you don't regenerate twice, and so then you end up with the wrong version on stuff. Problem is I made a mistake. But if I kept spelling it that way in all my code, it would be okay. That's why we're all code. Oh yeah, so, okay, so far, up to this point, you can't read it yet. So far up to this point, we've been talking about what works out to be things that we do in compile time that eventually help us in our runtime environment, right? Well, let's talk about something a little bit different. Let's talk about, can we do things in compile time to help us out, but we don't ever want to see the effect of them at all in runtime? That's a little different thing. So let's do this. The word problem of the day. How many of you loved word problems when you were in school? Wow, less than I thought there would be, to be honest. That'd be a bigger number. All right, for those of you who know anything about me, you know I like butlers and slushies. So, butler drops a slushie from the second-story cottage window. The window is 6 meters above the garden. How long does it take for the slushie to plummet to the tomato bush? For all you pedantic people, the tomato bush happens to be at 0, okay?
And we're assuming that the window is right over the...
And we are assuming that the window, yes. All of those types of things, like just as if you were in high school and you didn't know anything, right? It just said Newton existed and that was it. You believed everything else from that point on, right? What's that? In a vacuum. It just so happens Butler lives in a vacuum, so it's okay. On Earth. You have to say on Earth. On Earth.
At sea level.
Are we covered yet? Probably not, but tonight we are, right?
Sea level.
All right, so here's the problem, and if you don't remember it well enough, if you end up having children who go through elementary school, you get to remember all this stuff again. And what the first thing is you end up remembering is you want to teach your kids to do dimensional analysis. We don't call it that necessarily. We might say, work out the units and then make sure it makes sense at the end, right? Well, we don't do that in our software. We probably should more often because wild things can happen. So if we were just to work this thing out then, dimensionally, we have height. It equals 1/2 GT squared. Which, then if I want to figure out the time, then I have time equals the square root of 2 times my height divided by G. Good, right? We're all there. So, in my textbook growing up, the gravitational force was 9.8 meters per second squared. For some reason, my children have textbooks that say 10. And I really don't understand that. It's really wrong, okay? It's not 10. All right. So we can go ahead and plug in G, and we can plug in H. Things are good. So for our units, we end up doing something like this, right? Time is this stuff. Meters divided by meters per second squared. And that should become the square root of seconds squared, which should become just seconds. So then I get time out. And if I worked all this out and things were great, I'd be happy and I'd get time. But if I came out with something like meter seconds, I'd go, oh, I did something wrong, right? My calculation was wrong. Now, if only the computer would do that for us. So, you know, if I got this out, seconds squared, that would make me sad too, because I forgot to take the square root of it. That never happens in programs where you forget to do a step, right? Yeah. All right. So, let's do it in code. We have taken now, D is 6, G is 9.8. I'm going to do this, and I'm going to print it out, or not. And what happened? I can take the square root, right? So I got the wrong answer. It's pretty close. But I got the wrong answer. And this bug could just lurk around for a long time. So it would be nice if I could like teach the computer to do the same thing that I teach my kids to do. This would be awesome. I have a length, and I have an acceleration, I have a time, and I can say this is meters, and this is meters per second squared, and I do all this stuff, and they're nicely highlighted, and then I get this. No viable conversion from whatever this thing is to a time. Wow. If my compiler would output that, I'd be a very happy man. And if it would do that without having any runtime overhead, I'd be even happier, right? All right. So, here, we've made the change. We put square root in because we listened to our compiler. And it's happy. It prints things out, it even gives me units. Life is wonderful. How many of you use the units, boost units already? Oh, awesome. We're not spoiling too much yet, then, are we? All right, this is cool. This is really neat. So we want to do this with no runtime execution cost, and we want errors reported at compile time. Right? That's what we desire. Yes?
And I want readable errors reported at compile time.
Hey, that wasn't so bad.
That's not what I did.
Well, this is plain, and this is what you'll get. Chandler's not in here, but he'd be happy to say, you know, this is cool. I don't know what compiler you use, but you should use Clang.
That's so much better than the 6-page output you get normally.
Yeah. Right, just use Clang. Right, if you were here 2 years ago with walk-free stuff, it was just like, just use a walk. All right, so at runtime, these are the types of things we might want to do. There's lots of papers on this stuff, right? So we're not going to go into this too much. And you can read it in other places. But at runtime, there are people who study this type of thing. We might create these arrays and describe what the different base unit dimensions are. And we're going to have one for mass, we're going to have one for length, and we're going to have one for time. And then we can go ahead and figure out what power we're going to have, right? So mass, length, time are simple, and acceleration then of course is length divided by s squared, or times s to the negative second power, right? So we have a way to describe this. This is great during runtime, not so helpful though during compile time. So, compile time, we have this instead. And if you were to pick up Dave's book that was at the beginning of my very first slide, you will see this in it. Okay? So, remember that was the one of the 2 books that you want to buy. And it goes in great gory detail. We're not going to. So we have this thing though, it's called an NPL vector, and it allows us at compile time to have that same concept. What types are going to store in it? Ints. Cool, let's set them up. Mass, length, time. Let's set up an area. And let's also set up an acceleration. So it looks a lot the same, right? But this is going to give us that same concept of like an array, but we're going to be able to work on it during compile time. We're going to be able to do things with this thing during compile time. All right, here's our wrapper for a quantity. What does explicit mean?
No automatic conversion.
All right, so it's going to take a t and the dimension. T is what I'm storing. It's the type of the thing that I'm storing, the wrapper, right? I can get t's back out. So at the end of the day, what does this really do? Nothing, right? It holds t's and it gives me t's back out. Do you think the compiler can figure out how to store t's and give me t's back out without doing a whole lot? I would hope so. All right, so we can now do things like saying, I have a quantity that's double, and length is its dimension. And I have a quantity that's double, and time is its dimension. Where am I storing the dimension within inside of here? It's part of the type. Right. So quantity and a quantity that takes a double and is of type with a length type of the dimension is a different type than the one with time. Right? It's just part of type information. I don't have to store this anywhere. Oh, and then I got this thing, d equals t. D equals t. And this is so awesome. I mean, I don't have to do anything else. And right away, I get this no viable overload, dt, get a new compiler, Clang just tells me. It's awesome. All right, let's do some addition. I want to be able to add my quantities. So I'm going to have an operator plus. It's going to take quantities. And notice it's taking quantities of the same type. And it's taking quantities that have the same dimension listed. So they're both going to be ints, and they're both going to be of types length. How do I just add things that are of similar types? Well, just add them, right? It's pretty straightforward. So I'm going to return quantity of the same thing, its value plus the other value. Don't have to think about it, right? Adding's easy. How are we going to subtract? Subtracting's easy. So adding and subtracting things of the same dimension, we just add and subtract. Piece of cake. All right, let's do it. So we have a time, t1, and a t2, and we have a length 1. And then I've taken t2 plus length 1, and I've assigned it to t1. And Clang tells me that this isn't going to work. Invalid operands to binary expression. And then it's trying to tell me a little bit about it, right? This quantity time and quantity length. It doesn't know what to do. One of them's a time, one of them's a length. So I've done nothing else, and the compiler's already being very nice and telling me a lot of things. All right, so let's fix it. We're going to add times together, and bam, we get time. All right, so we can add. Now we want to make sure that there's no price to this, right? We've shoved something into this wrapper, we pulled the things back out the wrapper, right? This type of thing here, we shoved it in, and this was taking the t and we're returning t's, we could stick t's in, but I'd really like to make sure that if I was doing this with time, that this code should look identical to this code, just doing it with doubles. That's what I would like to know, right? If I just do this with doubles, do I get the same thing? Because if so, I'd rather do it and get compiler errors when things don't match. All right, so here is if you take an O2 output, and the important parts you will want to care about are here, and here, and wow, those compilers are so darn smart. So the compiler, of course, has no overhead. It's able to do exactly what I want. My wrapper doesn't do anything additional at runtime. All right, let's multiply them. Because if we're going to get these things for free, let's just keep doing them. How do we multiply? Things of like type, but the dimensions could be different? So if you have something length times length, you get length squared. So it's just as easy as adding up the exponents, right? All right, so we're just going to add the exponents. So here we go. Let's just go down here for a moment. The value is simply value times value, right? The dimension portion, we need to add them together. So how are we going to do that? Well, that's weird. Luckily for us, MPL has all this cool stuff already built in. So our return type, first of all, is just going to be the same type that we're storing, int, double, whatever. But the type dimension that's being returned, its exponent, will be the exponents added together. So that's as cool as using MPL transform of D1 and D2 and taking, those are placeholders at compile time, and this is saying add them together, get the type back out. So the end result of if D1 and D2 are, remember these things are those arrays. They're compile time vectors of dimensions. If we take the dimensions, those arrays, and we add the arrays together, we're going to get the final dimension. What is meters times seconds? Meter seconds, right? So we want to take the whole arrays and we just want to add these arrays together. That's what that does for us. It's going to take that array and that vector, MPL vectors, and it's going to go through and add them together, all the different elements of it. And I'm going to get back out a new MPL vector that matches the addition of the two that I had at the beginning. So down here, what's my dimension? Same thing. Return quantity, the t, and then the dimension.
So if you're, not in this case, but if your dimensions were just single numbers,
Yeah.
then you would just be able to use plus by itself, right?
You just add.
Because it's a vector, you have to
Right.
basically iterate.
This is a vector, so we have to, in essence, iterate through at compile time the vector, and we're not going to talk about that, but you want to pick that book up because it's amazing. And at compile time, you can then iterate through these vectors and do things. Transform does that for us. Transform is going to iterate, and it's going to, in this case, this is a meta function, right? It's going to apply that. The result is going to eventually come out into this new type. Just like STL, right? We have transform already. Input, and then what do we want? Where do we want? What do we want to do with it? And then we're going to get a new type out. The whole MPL library is like that. It's got all these things that you're used to using inside of the standard. All right. Nice highlighting that I didn't use. Okay, type back up. So now we have length, and area. We're taking and multiplying these two distances, length and length. We should get length squared, which is an area. And now it tells us no viable overload. That's really annoying because it should just work. So this doesn't work because we made our constructor explicit. And so now we want to get rid of the explicit. So before we made it explicit so we couldn't assign things that were of different types. And now we have to get rid of it so that we can assign things. But that's okay because we can do this, boost static assert, and we're going to make sure that the dimensions are equal. Let me explain why we have this problem, and then we'll get there. So here, this is going to describe an area, which is going to have the MPL vector like we want it to be assigned, but it's of type area. And when we get done with the transform, it's going to return another type with the same information in it within the MPL vector, but they're of different types. And that's a pain. So what we're wanting to do is make sure that, yes, the dimensions are the same, because that's what we care about, even if the types are different. So again, this is a static thing, right? It's not going to happen in runtime, it's going to happen in compile time. If for some reason these dimensions are different, we're going to get an error. Now we're safe. We can assign things that have the same information in the vectors, but even though they're different types. All right. So now we try to multiply these. We get this, and if we were really nice and made this a boost static assert message, we could actually put a nice message in here. Again, no runtime execution cost. Errors are reported at compile time. Scaled units and conversion factors. All these things are in this boost units library. So if you're not already using it and you do something in your normal daily job that might require dimensional analysis, this is a great thing to use. For a period of time, I worked at a weather company. They did ground-based weather systems. There's like dimensional analysis all over the place and calculations that help land airplanes and do other crazy things. It's really bad if you get it wrong. Well, we didn't have a way to do this back then. It would have been nice, right? It's nice to know from the compiler that you've done something wrong in your calculation as opposed to just leaving off the square root and not allowing airplanes to land, or allowing them to land when they're not supposed to. Right, that's boost units. It's 6 o'clock.
Could you use the normal type trait library to check if they are the same?
No. No, because they're not the same. They're really different types. And they're not, but there are these vector things that you want to see if what's inside of the NPL vector, if those are the same. So they're both NPL vectors, but they contain different information. All right. We'll stop here. Because it's 6 o'clock, unless anybody else has any other questions. All right, thank you very much.